data fits to our line or regression line of best fit. And we're going to start by talking about something called a residual plot. So a residual plot is a scatter plot looking at the residuals against the explanatory variable. And they help tell us how well a regression line fits our data. If there's no pattern, then a line is a good model. If there is a pattern, then a line is not a good model. So for example, in these two diagrams down below, you'll see that the plot that you see on the left, there is no pattern. What does that mean? That means that this is a good model. Or in other words, a line fits well for that data. In the second one, you'll notice that there's a pattern, which means the line is not a good model for our data. And that's the big idea behind residual plots. Down below here, we have instructions on how to create the residual plot. When we get to our data, I'll actually walk you through that as we go. But they are here in case you need to look back to see how to do this. You will have to talk about this on the AP exam when they talk about a regression line. So first of all, you make sure you put your X list in list 1, your Y list in list 2. That's what we do all the time. Stat calc number 4 or 8 if you want to find the regression line. And then you're going to highlight list number 3, and then you will make L3 be the residuals, and that's how you do second stat, and it'll just say residuals. You hit enter, and poof, all the residuals pop in there. And then you'll go into your scatter plot, which is the second Y equals, and then you'll make L1 the X stuff and L3 the Y stuff, and then hit zoom 9. And we'll do that after we enter data in our calculator, so don't worry, I just want to tell you what it was. When you talk about your residuals and how it relates to our standard deviation, if we use that regression line to predict the values, then down below you can find the standard deviation of the residuals using the following formula. So the formula is that standard deviation, which we're going to call S because we're working with a sample, is the sum of all of your residuals squared divided by n minus 2. N is referring to the number of items in your table. So in case that you want to remember that, this is the number of table items. And the sigma, again, means the word sum. And the S is standing for the standard deviation. And again, I'll show you how to do this in the context of one of our problems. What this standard deviation for us is doing is it's talking about what the average or typical or mean error would be based on our prediction. So we talked about earlier with this ramp thing and how far the Hot Wheels car would jump. Bless you. This is saying, oh, I think the Hot Wheels car will jump 12 inches. But I actually found out it was 2 inches or something like that. And you go, oh my God, I'm off by this much. Is that normal? You know, maybe that's your outlier because it's so far away from the average or typical error you would expect to see. So in this example, I think we did this one. I'm recording this now, so I'm saying it again. I think we did this one yesterday, maybe the day before. If you don't still have this in your calculator, make sure that you put the height in list 1 because that'll be our explanatory stuff, and then our response stuff will go in list 2 or our Y values, and then after that we'll do the problem together. So first, let's work on creating a residual plot because that's kind of important. So back from my residual plot information, if I go to my calculator, I have all this data in here. And in order to create a residual plot, I need to go into my Y equals. Oh, actually, I need to go to my L3, don't I? So arrow over to L3. And then we're going to arrow up, hit enter, Let's see if I can do it that way. Stats. No, that's not going to work. My bad. All right, let's try it the other way. Don't hit enter. Arrow up to L3. Don't hit enter. And hit stats. No. Second stats. Did it twice. Because I don't pay attention to my own notes. Second stat. See down number 7? It says residual. So you can just go 7. I just push the number 7. And I hit enter. Poof. These are all my residuals.
Error data type.
Let me pause. Okay. Let's go to our y equals. Dang it, there's nothing in there. So let's quit out of this. And let's go stat, calc, number 4, because I like that better. Enter. Whoa, what just happened? What is this?
That's your linear regression.
That's my regression equation. Then I'm going to go to my y equals. And then I'm going to go vars, statistics, equation, enter. In my stat plot, if I turn these on, and I draw my scatter plot, this is what we saw yesterday. My regression line is going through all my data. Good so far? Okay. So then, if I go back to my stats, and I look at my list, and I arrow up, and I go second, stat, residual, which is number 7, enter, I have 0.84444. So now what I'm going to do is I'm going to draw this residual plot. Second, y equals. This takes me into the plots. I hit enter twice, and I want the residual plots. Which one is it?
Y list is L3.
The y list has to be
L3.
L3. So second, number 3.
Now zoom 9.
And then zoom 9.
Whoa.
That's about
Wait,
right.
Two. Once I have my residual plot, look at the window so I have some idea what's going on. Oh, my x minimum value is 0.6. I don't really like that, so I'm going to make my x minimum 0. My x maximum is 5.4. I don't really like that, so I'm going to make it 5 or 6. I don't know, because I go out to 5 for the x table. My y minimum is negative 1.78. I might go with negative 2. My y max is 1.8. I might go with positive 2. And then I'm just going to plot these points. Okay, so just so you know. So I go back to my notes. And if I'm drawing this residual plot, the big idea is number 1, you want to label your axes with the values. And then number 2, you want to make sure you tell the reader it's a residual plot. So off to the side here, this is what it looks like for me. I'm just going to go up to 5, I guess. And then what I said is going up to 2?
Yep.
Negative 2 to 2.
Thank you. And then I'm going to tell the reader that this is my residual plot. And so if I'm putting these marks on my residual plot, somewhere, this is kind of what it looks like. I'm trying to get close to it, but I mean, you're not going to be perfect, so just try to do the best job you can.
Does that mean the y-axis is just residuals?
Yes. And I'll put that on there in a second if that was confusing. Where am I now? 2.5. I'm somewhere around maybe a quarter. 3, I'm maybe less than that. A little bit past 3, I'm just under that. 4, I'm down at negative 1.5. So right over here. 5, I'm here. And then 5, I'm somewhere around here. Okay. So this is my residual plot, and of course you should, these are your residuals over here. Bless you. What do you notice about this plot?
No.
There's no obvious pattern. So since there's no obvious pattern in here, I guess I would say something like, since our residual plot has no obvious pattern, and the residuals are pretty small, the regression line seems like a good model for the data. So since there is no pattern, and the residuals are small, our regression line seems like a good model for our data. So first of all, we found this residual plot. That was the first thing that we did. The next thing that we're going to do is we're going to find the standard deviation. And then the last thing that we're going to do is we're going to interpret it. Okay, so 3 parts. Part 2. Find the standard deviation. So from the previous page, we know that our standard deviation is the square root of the sum of the residuals squared divided by n minus 2. So here's an easy one. How many things were in the table? 8, 9, and 10. Excellent. That's great. Let's try our counting again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, n is 9. So down here in the bottom of the fraction, that n is going to be a 9. Just so you know. And then if I want the sum of my residuals, I can go into my calculator. And I like to do it this way. If I'm in my stats, look at list 3. What was list 3?
Residuals.
The residuals. So if I go stat, calc, one variable statistics, but you want to do it on L3, because that's where your residuals were. This
It's the same stuff I got.
EX squared is the sum of that list squared. You might want to write yourself a note.
What?
EX squared, list 3. It's recorded on video, so if you can't remember, it's there. EX squared from list 3. So now I go back to my notes. And this is really like saying S equals EX squared of list 3 over 9 minus 2, and take the square root, which, if I look at the EX squared of L3, that was 4.87 what?
2.
Can I have a couple more?
4.872222.
Good enough, okay. Over 7. So you type that into your calculator. When you get done, you get that your S,
873.
873, thank you. This is my standard deviation.
I'm sorry, 834.
I got
Okay.
0.69.
Well, 69, whatever is wrong. So just erase it and put mine down.
Alright, sounds good.
All right. So what was it again?
0.834.
Okay, so we're going to go with 0.834 this time. Does that look good? How many people got that? Okay, I feel more comfortable. I feel more comfortable with that. Okay. So, pick me, pick me. What does it mean? So our standard deviation is saying, on average, our prediction